All right, this is the last of the proficiency problems. This standard says I can calculate the work done by a force. This is ETM4. Okay, and the problem says you push this 70 kilogram person with a force of plus 100 newtons over a distance of 0.25 meters. So they will swing higher. Estimate the work done of each push if each push takes 0.2 seconds. All right, so if you look at your MCAS formula sheet, you will find that the formula for work is that work equals the change in energy, which is also the same as force times distance. I think it's going to be most useful to simply ignore the change in energy part and just say that work equals force times distance. Right? I'm just saying the same thing, I'm just saying less, really. Okay, so we are being asked to find the work. Our problem is already solved for work, so we do not need to use a formula triangle to sort of parse this out. We are given a force. The force is 100 newtons. And we are given a distance, which is 0.25 meters. And 100 times 0.25 is a quarter of 100, which is 25 joules. Now, you might be wondering, aha, but what about the 0.2 seconds? In the formula for work, there is no stipulation about time. For work done, it doesn't matter how long you did it for, how long it took you to do it. That is in the realm of power. Power is work divided by time. But we're not being asked about power here. So the fact that it took 0.2 seconds means nothing to us, and we leave that information alone. So the answer to D was 25 joules, because the force was 100 newtons, the distance was 0.25 meters, multiply those out to get 25 joules, and forget about the time that it took to do it. So that was a little trick.